back and we can say, I've tested your apps, here's a report of all the vulnerabilities in the app. My first question to you is going to be, how much of the app did you cover? How do you answer that question? How do you answer that question? And the last piece of this is, in the QA cycle, we highlight key business logic, right? We look at business logic because that's what we're supposed to do. That's the point. We look at exercising business logic and making sure that that business logic does what it's meant to do. In InfoSec, we highlight what we call found functionality. We find things that are not supposed to be there, and we put them in the spotlight, draw a big red circle around them, and go, look what we found. Look, I can put this script tag in here, and I can completely exploit all this over here, and by this very simple token moved over to this, like this, and all of a sudden this database becomes exposed, and bet you didn't intend for that to happen, and developers just sort of go. But the whole point of this is, this type of testing on both sides is totally divergent, but at the end of the day, we're actually trying to do the same thing. We're testing the application, right? So the premise here is security analyst tools today aren't equipped to properly test highly complex applications. Anybody disagree with me? And highly complex applications, I'm looking at the Amazons, the eBays, the typical large application that requires more than a simple crawler to dissect and map the application. So we have some missing pieces. Understanding of the application is missing. Functional mapping of the application is missing. Execution flow of the application is missing. Usually we can draw DFDs based on static analysis, but actually mapping the way the application flows is different. And while we may have all the cool patterns of different script tags and different ways of exploiting the app, generally we don't get a whole lot of valid test data to work with in security. Again, this is a problem because that prevents us from navigating the site correctly. A brilliant example of this is, if you'll allow me, if you have an application that requires you to register to do something, right? Register an account to do something. Generally, it requires an email address. Even if you're allowed to provide information, right, map some data onto the flow of that application, to test that form or that flow correctly from blank to confirmed account, you have to be able to provide an email address every time you roll through that cycle, and you can't reuse that same email address. So you have to have valid test data for people that are going to be valid within that system for however many loops you want to execute. How many times do you get that if you're doing security testing? Probably close to that. So there's a gap, and this gap is ugly, and unfortunately it's a cliche, because in security, thank you, Dennis, in security we tend to use what I like to call the kitchen sink approach, right? We throw the kitchen sink at the app, we take out the 25-pound sledge and beat on it until something breaks. That approach used to be really good when applications were fairly low complexity and we could actually easily beat on them and break them. But now that they're getting more complex, more and more of the applications are becoming non-reachable to standard methods of attack. To you and me as a tester, not as the bad guys though. Keep that in mind. So the you are here, they are there. Unfortunately, the ideal is someplace in the middle, right? The QA folks that are doing testing are on that side of the bridge. You're on this side of the bridge doing this anti-testing. And where you really want to do is someplace in between the two. And so as all this is happening, and unfortunately technology is not standing around waiting for us to catch up. Because what's really happening is you've got this concept of application state, and it's drastically changing, and it's changing as I stand here and speak. It used to be application state. In fact, arguably the browser was never really intended to understand the whole concept of state, but let's get past that. So we built state machines and ways of tracking state, and it used to be we could attach a cookie, and that was state. Well, now we've got a whole bunch of client-side stuff that happens, and now we've got client-side state. So we've got HTTP state, server state, client state, and now it's cookies, server state, JavaScript. We've got Flash and Silverlight. We've got all sorts of other things happening. So the concept of state is now becoming even more complex. So how do you crawl all that? Right? It's impossible to decouple the idea of HTTP from the client state now. It's also becoming that you can't just crawl and guess your way through a modern, complex application. I hope I've made that clear in how I feel about that. So there's this proposed approach. So we're going to I want to combine functional and security testing. I want to compensate for the explosion in technology. So I want to address technology complexities and address functional complexities as well. Addressing technology complexities like session states, the variations on session state management, whether it's client or server, and code complexity, all the different frameworks, all the different ways servers understand who you are, what you're doing, what actions you're performing, what page you're on, what account you're transferring from and to, how much money you're transferring, all that fun stuff. And address the functional complexities like mapping application function as this concept called execution flow, and then mapping data to drive these execution flows, right? So mapping the app through an execution flow and then mapping data to it to drive that. So my contention is that there's some incoming new automation technology. And this isn't going to have to depend necessarily on technology specifically. This is stuff that you guys can go back and do right now and start working on it, start using some of this. Some of these concepts really aren't all that magical, and you don't have to wait for something you can buy or something you can code to start using some of this methodology. So standards and specifications, I'm working on these types of specs, an EFD and an ADM, and I started the frameworks for these already. I'm just kind of running out of time. I wanted to have them mostly done by today. Unfortunately, it didn't happen. The execution flow diagram is a functional path through the application logic. And so there will be many functional paths through the application logic, potentially hundreds, maybe thousands. And if you have a really complex applications, if you run in the millions, you might want to start segmenting things. And an application data map, which is a mapping of data requirements against functional paths. So if you look at the application, how do I get from here to here? What data is required to make that continuity? What data is required along that path? And so improving this testing process and improving the idea of security testing isn't just today's approach of I've got a URL, I've got some credentials, I've got my 25-pound sledge, I'm just going to beat on it over the weekend until something breaks. Let's make this a little bit more enlightened. Let's see if we can produce some actual results out of this that we can do something about, that we can then measure some success based on. And it's looking at functional specifications and really starting at functional spec. How many of you guys do security testing and actually start at functional spec? That's a very low number. Mapping that functional spec into that EFD, mapping data to that EFD, and doing functional-based automated testing, so letting the automation do all the dirty work, right, the easy stuff, which means that the automation that you'll be using gets a lot more intelligent and isn't just point and shoot anymore because of what you've done up until then. And then manual result and coverage validation. So this isn't looking at an application and saying, I have to test this app. This is looking at an application and saying, I'm going to let automation handle these, the parts that are accessible, and then I'm going to handle the validation of these results. It's a different mentality. It allows you to scale a lot further out in terms of how much resources you have to throw at a problem, a security problem, an addressability problem. So let's talk about the EFD and ADM basics. I'm going to walk through these pretty quickly. So the EFD, a basic concept, it's a graph of flows through the application. It's nodes, edges, and paths. The nodes represent application states. Edges represent different actions. And the paths between the nodes represent state changes. Okay? It's like a Visio diagram. Right? Boxes, arrows, and stuff along the edges. And a set of these we'll call a flow. And essentially a flow is a series of flows is what makes up an application. Now, what is an action? How do we figure out what to draw, what to map? Well, that's an interesting question. An action is something that causes a change in state. So remember the concept of state that we said earlier, right? Client side or HTTP side. A human server or browser-driven event. Human server, pretty much limited to anything. And there's three types of actions. There are direct, supplemental, and indirect. Okay? Direct, supplemental, indirect. This is kind of key to the whole thing. Now, direct flow actions. Actions which change the browser's document context. So this is a completely and entirely new refresh of the DOM, an entirely new browser page. So you get a full frame refresh, right? Your browser goes blank for a second. So an example, you follow a hyperlink or you click on a login button, something happens, you get a totally new page, and you get a diagram, looks something like this, right? You get a P1 where you started, a P2 where you ended up, you get a line between them, you get a get page, and the HTTP states are the two pages, and a direct flow action is the line between them. And this is about as basic as it gets. Any questions on that? That's pretty clear? Sweet. It only gets more difficult. So supplemental flow actions, actions that change the state of the current document. So the current DOM state changes. Right? So client-side actions, maintaining the browser page you're already on. So things like a JavaScript menu. So your mouse over events. Right, on mouse over, those kinds of things. Your cascading menus. A lot of this is Flash client events. So again, the map becomes P1, P1.1, P1.1.1. Right, these are just DOM state changes, but it's all within the same context of the same page. All good so far? And just to completely confuse everybody, indirect is actions that are automatically triggered by document context. So these are things that supporting data, modifying document state. So some of the examples in this are like libraries that are loaded, stock tickers, XML HTTP requests that are made on your behalf by your browser that you have no control over. Things that just sort of show, if you've ever been to a site that has Google Analytics, you didn't request that .js file. Clearly, sometimes you don't even want it to fire, but it does, right? So these are represented like so. I don't have a laser pointer, pretend I do. And they're basically indirect. Direct, supplemental, indirect. And they all have their own little boxes and circles and triangles and lines and dotted lines and arrows and so that's the part we're standardizing now, trying to figure out what boxes and stuff follows what. Actually, I don't need any more, Jim, but thanks. So basic ADM concepts, application data map concepts. An application data map defines flows with the context of data. So this is data-driven testing. I mean, guys, we've been talking about data-driven security testing for I don't know how long. I know many of us haven't been paying attention, but that's a different story. Flows mean nothing without data. So a lot of these flows you can draw, but if I strip away all the data on them, it's just boxes and arrows. Because 90% of the time, once the application complexity starts to ratchet up, I can't ever get past like the second or third box without